Hey, third graders. It's so great to, well, I was going to say see you, but that's not the case. Hopefully maybe to see me. I don't know. All right. Well, I just wanted to let you know that also at your material drop off, you got this packet of like extra papers here. For Unit 7, it has our family letter on the front. And then, right here we have the, which way? Here we are. Step warm up questions. So if you wanted to do your warm up questions on this page, I know you already did number 1 with Mrs. Fiddler last week, so you can get this out if you, we're going to work on number 2 today. So you could find this packet of papers and we're going to work on the 2-step warm ups. So also, what you're going to need for today is our Number Pieces website. You'll be needing to use the 10s and the 1s. So if you want to get that set up, pause the video right now and then come on back when you have all of your pages ready to go and your website. All right. Okay, so today we're going to start with one of our warm-ups here. Again, we did number 1 already with Mrs. Fiddler. Now we're going to go to number 2. For each of the problems, we're going to tell what the problem is asking you to figure out. We're going to write an equation for that problem, and we're going to use a letter to stand for the unknown quantity, and then we're going to solve that problem. So let's go down to number 2 here. It says Micah collected baseball cards and put them in a binder filled with pages that hold 9 cards each. His goal is to collect 270 cards by the end of the year. Right now, Micah has filled 11 pages of his book. How many more cards does he need to collect to meet his goal? All right, so first, what is it asking us? It is asking us to solve how many more cards does he need? Okay, so we need to find out how many more does he need. So he has some, and his goal is 270, so how many more does he add to that? Okay, now we have to go through and figure out an equation for this problem. We have to use a letter for the unknown quantity. We call that the variable. Okay, so Micah collects baseball cards and puts them in a binder filled with pages that hold 9 cards each. His goal is 270 cards. Right now, he has 11 pages in his book. Okay, so what they're saying is that one page holds 9 cards. And he has 11 pages in his book. Okay, so right now we could just figure out what it is, like what that is. But we're just going to be writing an equation for it right now. We don't need to solve it. But we know that his end goal is 270. So we have to somehow get to 270. Let's take a look at the equations that they're telling us that we have options for. And let's see what we have here. So if we took 270, subtracted 9 times 11, that would tell us how many cards we would have left. Kind of makes sense. Like, here's my goal. Here's how many I have in the parentheses. So I'm going to subtract what I have so far. That one could work. So we could take how much he has right here, like how many pages he would have, plus whatever cards he would still need, and that would get 270. That one would match as well. And then we're saying he has a goal of 270. We can take away how many cards that he still needs to get, and that should equal this here. Okay. Let's see. How do we want to go about doing this? You know, I'm kind of thinking, my brain started thinking about doing number 2. That one just kind of seems to jump out at me because I know from your lesson you did with Miss Fiddler that you guys all did 11s. So I know that we can solve 9 times 11 quite easily. That would be 99. And now I just need to figure out how much do I need to get to 270. Okay, so I'm thinking I want to do this on a number line. You could do 270 minus 99, but I see that the 0 would be on the top of the 9, and that would mean a lot of borrowing would happen. Plus, I know 99 is extremely close to a very friendly number of 100. That makes it really easy to just jump 1 to get to 100. Then I can jump 100 to get to 200. And then I can just add 70 to get to 270. So that to me is in 3 steps versus all of that borrowing. This was a much easier way to go. So now I just need to figure out how much more do I need to add to that? And that would give me 171. 171 donkeys? What are we talking about? It never ever seems to end up being donkeys for some reason. I am thinking it can't be donkeys. So let's go back to my question. How many more cards? Oh yeah, he needs 171 more cards. That would be my answer. So that's our warm-up. So for today, everyone, we are going to be working again into multiplication. I think you're going to be able to solve this answer or this problem here because I know you did times 11 with Miss Fiddler last week. So you can do this one here. What is 2 times 12? I wish I was here to see your thumbs. 2 times 12 is 24. There are going to be a couple different ways that we can go about solving 2 times 12 is 24, okay? One way is by using your number pieces. You could have 2 12s. Okay, we have 2 12s here. And you can add up the 10s. 10 plus 10 is 20. You can add up the 1s, 4. So 20 plus 4 is 24. You also maybe didn't even want to use those, and you know that 12 plus 12 is 24, just by doubling. Okay, so we can figure it out 2 different ways. Now try this one out here. See if you can use those base 10 pieces. I know it says work with a partner. We don't have partners. Maybe you have a mom, dad, brother, sister, dog, someone you want to work with. But you could use your number pieces here to help you. Okay. I am going to start off with 12. 2 12s, and I'm just going to add another 12 to this. Okay. So now all I'm going to do is add up the 3 10s is 30 and add up the 6 1s is 6. So that gives me 36. You could take what we did before because you know that that's 2 12s and then just add one more 12 to it to get 36. That way too. Nice. So here's the 10s, the 6, the 1s, and add them together. Okay, so now we can build a times 4 and times 5s. So I already started the times 4 here. Same thing, looking at our tens, 10, 20, 30, 40. So this right here is 40. 2, 4, 6, 8 is 8. R times 4 is 48. Okay. Now I could just add on to that to get 5 times 12. So I'm going to just take that 48 plus 12 more. If I just added on one more 12, and that one will get me to this right here is a 10, and this is 50. 50 plus 10 is 60. And 20, 30, 40, 50. Right here is 50. And then 2, 4, 6, 8, 10 is 10. So 50 plus 10 is 60. So you can use the visuals of our base 10 blocks and count by tens and twos, or you could just build off of what you've already solved. So we've done a lot of these. We know 1 times any number is that number. So 1 times 12 is 12. We solved 2 times 12. That one was 24. Counting up by 12s, 3 times 12 was 36. 4 times 12, we just finished 4 times 12 in the green was 48. And 5 times 12 is 60. Okay, we can use that to help us build and solve our problems here. Now, I feel like you've got a handle on some of this. If you want to go through and solve the 6 times 12, 7 times 12 by building it with these base 10 blocks, you most certainly can do that. To try to keep our video a little shorter today, I'm going to hop down to our bigger numbers that we have here, okay? So let's start here with 10 times 12. If we have 10 12s, I could count by 10 12 times. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's only 10 tens. 110, 120. So you could just count by tens that way. But I also think that you could do it with an area model. I know Mr. Gobler is a huge fan of the area model. If you do 10 here, and this length is 12, well, I could just split this so that it ends up being 10 plus the 2 over here. You see those 2 right here? And this part right here is one of them, and then this other part here is 2. Okay, and what I'm saying is this all the way across is 10 blocks. So it's basically like I'm using the base 10 here, and I'm saying 10 and 2. So here's 10, and then these are 2 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So I could take this part right here, which is 10 times 10, and that equals 100. And now, since I know this part over here is 10, this is saying that this part is 10. So now for this part here, I'm just doing 10 times 2, which is 20. So I'm going to add the 100 and the 20, and I get 120. That's a good area model way of doing that. So I could just take 120 plus 12 to get my 11, and then I could add 12 again. But what if I didn't know 120? Okay, I didn't know the one that we have above it. I, again, am going to split that up into area model. I'm going to do 11 and 12. Okay, I'm splitting that 12 so that it ends up being 10 and 2. Those are easy numbers to work with. And then that shows that this area here is going to be my 11 pieces. I'm not going to draw 11 in there, okay? So now I see here that I have 10 times 11. Oh, well, I know you just figured that out with Mrs. Fiddler on Thursday, and that it's not going to just be doubling that number 10 and 10 to get 1010. I know that you guys first thought of it like 10 times 10, which is 100. And so then I have one more left over because it's 11. So now I can just do 100 plus that other group of 10 to get 110. So this tells me that this area right here is 110. But now I have this part right here that I have to do, which is, again, since this side is 11, that tells me that this side is 11. So now I have 11 times 2, and we figured that out as 22. So all I have to do is put them together, and I have 110 plus 22, and that equals 0 plus 2 is 2, 20 plus 10 is 30, and then I have my 100. So I have 132. That is my total answer, 132. And the same thing goes with 12 times 12. 10 times 10 is 100. We know that part. I'm going to give myself some space to work. I like that area model. It splits it up quite nicely. So I'm going to split my 12 into 10 and 2. And guess what I'm going to do with this one? Because this also will be 12 on the side. So I'm splitting that now into 10 and 2. Because I have 12 times 12. So I have 12. 10 plus 2 is 12. Times 10 plus 2 is 12. All right. In this box right here, we have 10 times 10. Because we know how to do area now, and we know that it is the height and the width. And that's 100. Now, in this box right here, since I know this side is 10, it tells me that this side is 10. So I have 10 times 2. 10 times 2 is 20. In this box right here, since this side is 10, I know this side is 10. So I have another 10 times 2, because this is the 2 right here. So that's 20. And then I have this little one right here. And since this is 2, this side is 2. Since this is 2, this side is 2. So this is just 2 times 2. It's just 4. Now I'm going to add them all up. So I have 100 plus 20 plus 20 plus 4. So that gives me 100. 20 plus 20 is 40, and 4. 144. That's my answer. So when you're working with your 12s today and you are working into your student work pages, use this to help you with your blocks. You can use your 10s and your 2s and count by 10s and 2s. That's a great strategy. You can build on the numbers you know, like 12 plus 12 is 24. So then if you needed 3 times 12, build that, it's 36, okay? Now, you can also use the area model when it gets into the bigger numbers so that you can split that 10 into 10 and 2, and then you put that other number on the side and then multiply those into those smaller rectangles. You are good with that. So you are going to be working on pages 227 and 228. Those are going to be working with your multiplying by 2 or both by 12. For 227, you're multiplying by 12s and working on story problems, which we've done. And then 228 is by 11s and 12s using fact families. All right, you guys did an excellent job. Looking forward to learning with you tomorrow. Have a great one. Bye, everyone.